pot system. So as we all know, yes, there is a immediate emergency to address the climate change and global warming. And as we already know, India and China and Asian countries, they are already feeling the pinch of global warming for at least last 1 decade. But it has not made any impact because we have not stressed the need of tackling global warming. Because already we have a lot of heat. But now, fortunately, European countries, USA, all they have taken a very serious note of it. And that is what I mentioned here, that 77% of adults in the US, now they are feeling that they have experienced extreme weather in last 5 years. And as you know, concrete is worse for the climate than flying, approximately 3 times more. And as you know, Alki, that there is a need to cement industry because every ton of carbon dioxide, ton of production of cement release 1 ton of carbon dioxide, which is not true. It is less than that. But of course, that again we had that Paris agreement, which is yet to be really need willpower at global level to implement it by the developed countries. Of course, if we go further, now at least USA has gone very seriously, and in 2021, that California became the first state in the United States to require mandate reduction from cement manufacturing. And under that new law, the carbon emission from cement products in the state must be cut by 40% by 2035. Similarly, New York also has passed a law. Similarly, in May, this is a wonderful development that a big organization, big corporations like Microsoft and Google, now they have pledged an international economic summit to begin purchasing low carbon version of cement, steel, aluminum, and other major construction commodities that typically have a high carbon footprint. So from this slide, what we want to draw attention is, unless our governments all over the world are making law for development of advanced material to tackle the serious issue of climate change and global warming, the pace cannot be picked up. So it is my humble request, all the dignitary attending this international conference, to make a note of it and send to the all the highest authority of all the countries in the world. Then only it can be implemented, and it has to be implemented jointly, not individually, country-wise. I am not able to change the slide. Can you help me, please?
Can you click that right arrow or something like that? It may move.
I'm trying to do it. I approved the remote. Yeah, now, yes, it has come. Yeah, okay. So now that how to go about all this thing is, so the answer comes that climate change and global warming is already related with the sustainability issue also. And the sustainability, the word sustainability, it means we should be able to achieve zero waste concept, because unless we are able to make material which help us in utilization of industrial waste, there cannot be any sustainability. And the answer is, fortunately, we have a wonderful material, not only for next decade, but it is going to be for next 1,000 years to come. And the solution is geopolymer, because it is only geopolymer which can withstand extreme environment for 1,000 years. And it is a proof that Egypt pyramids are still during animation. You cannot control the shade. Why are you? Please help me kindly. Dr. Sheikh, please. Okay. So, yeah, most of the dignitaries in the attending conference, they are aware about geopolymer, because a lot of work has been done in last 40 years. And the father of geopolymer is the Professor Devoto Weeds. And we are highly obliged to him for finding this word and for emphasizing the science and technology based on geopolymer by arranging every 6 months a conference on geopolymer. Yes, of course, geopolymer is basically made using any waste, any material which contains silicon aluminum, using alkaline solution. And then there is a polycondensation reaction. And unless we have a SiOl linkage, it is not a geopolymer. Normally, people get confused about alkali-activated material and geopolymer. Alkali-activated materials are different than geopolymer, because for geopolymer to be called it, or to have function of it, to have property of it, there has to be a SiOl linkage. Unless it is there, it cannot exhibit its properties like acid resistant, corrosion resistant, fire resistant, heat resistant, and all wonderful significant properties which geopolymer possess. Now my again sincere request to all the audience, all the dignitary is, what we can take up immediately in the area of geopolymers. What are the immediate avenues and applications of geopolymer? Because geopolymer, a lot of work has been done. It is on the lab scale, and still it is struggling to come out of the laboratories. So first thing what we thought is, now there is a lot of concern about CO2 emission. And the moment we think of CO2 emission, it is only geopolymer, because the primary fundamental material which absorbs carbon dioxide is sodium hydroxide. And therefore, the very serious concern of CO2 emission, let it be from any industry, thermal power industry, or steel industry, or cement industry. The main concern is how to have dynamic carbon dioxide sequestration, and the solution is geopolymer. And then next I'm going to talk on fast and economic construction practices, infrastructure and precast construction, radiation, EMA, neutron shielding for important structures, water conservation and sea coast protection, and advanced geopolymer construction practices. So important thing here is, what is that circular economy? We talk of lot of circular economy. Circular economy is not getting practically implemented because it requires association, sincere association, abide by the rule and regulation of each country for each industry. Unless each industry waste material becomes a raw material for another industry, the term circular economy will become a fancy. So what I'm trying to say is, for example, first thing is there is a need of sequestration of carbon dioxide, and that has to be dynamic in nature. Dynamic means, what we mean to say is, as we are very well aware, that carbon dioxide emission from all these industries in gigatons, that is not in some tons. So to absorb so much carbon dioxide, there is a requirement of dynamic sequestration of carbon dioxide, and that can be done using geopolymer structures, which we are working on. And since being a matter of patent, we are not able to disclose the drawing for it. But in short, I can say that we are able to have a circular economy because the main material required for absorption of carbon dioxide is sodium hydroxide, and that we are able to regenerate by following the principle used in paper and pulp industry, wherein sodium hydroxide is regenerated by through lime solution. So here the only material which initially we need some sodium hydroxide. Afterwards, we are not depending on any virgin material. All industrial waste and products can be taken for making geopolymer structures, wherein continuous carbon dioxide can go on, and as long as there is scrubbing of sodium hydroxide solution, carbon dioxide will get absorbed at very high speed. I am aware of the work of Dr. A. Baharuddin. Fortunately, fantastic work has been done by you, sir. That wherein you have mentioned that depending on the concentration of carbon dioxide absorption in geopolymer, there is a variation in the mineral phases. It is a wonderful finding, sir. So, for that, we can easily predict what is the level of carbon dioxide getting absorbed with what speed by analyzing XRD phases, mineral phases developed in the geopolymer matrix. Second thing is, once we have this, the material used for absorption of carbon dioxide is not going to be the waste. It can be used again for structural activity. The concrete which are using for absorption, it because of carbon dioxide absorption, there are mineral phases, and it improves the strength of further mechanical properties of geopolymer structure which used for absorption of carbon dioxide, and that can be used for construction activities in various building material components. So this is the very important area which we need to work together, because the present all nanoid scrubbing is being done using organic polymer resin towers, which their production is a toxic, their use is a toxic, and their disposal is a toxic. So therefore, we have to concentrate on geopolymer based material because they are not only eco-friendly, they are sustainable, they are using industrial waste, they are again after their end use life, they are again a useful material, and that too environment friendly manners. The next, as you know, there is the inherent property of geopolymer is it sets very fast. When I was working on this, and I am a material scientist, and the team which helped me a lot, my whole of my career at CSIR AMPRI Bhopal, whether LKV geopolymer solution. Recently, Dr. Sheikh has joined to our group, a very intelligent, very innovative scientist. And what we understand is, generally we think fast setting is it is a negative point for geopolymer. But no, sir. By appropriating, controlling the setting time, now we need a material which sets fast. For example, runway repair, for making road, for making any structure which set fast, which saves the cost also. So therefore, there is a need to have a geopolymer based material which set fast, and as well as it is a cost effective construction material. And the basic theme for 3D printing is requirement is it should set very fast, because when we are doing 3D printing using conventional concrete, there is a need to add a lot of additives additionally to achieve fast setting, to achieve devoid of pole joints. Fast setting inherently is in geopolymer, and the one of the best property available in geopolymer is it is a devoid of pole joints in successive layer of formulations. That means we can go on adding layer by layer of geopolymer by using inherent property of geopolymer for 3D printing, for repair of existing structure in the form of stable geopolymer, having fiber reinforced geopolymer, and the unique property of geopolymer again one more is it has a excellent bonding with reinforcing elements used for the construction activities. For example, as we all know, the reinforcing elements are always based on steel, mild steels, steel-based infrastructure, and geopolymer has a chemical binding on that. Therefore, the pull-out strength is much more in comparison to conventional concrete. Second thing, when it is reinforced, it is having chemical binding with the reinforcing elements, which are generally metals. It imparts inherently corrosion-resistant property to the concrete structures. Because conventional concrete suffers from the corrosion of reinforced structure, which give the expansion of reinforced, and there is a damage for the total structures. Therefore, 3D printing, because it has an inherent corrosion resistant properties, it has a chemical binding with an reinforcement, and even for 3D printing activities, different kind of fibers can be used, and we can have desired mechanical, structural integrity, strength, and sustainability. And other than that, unlike other conventional cement concrete, there is an inherent fire resistance because of SiOl linkage. There is a chemical resistance because of SiOl linkage. There is a waterproof properties because we can have even ashes from bio waste. For example, rice husk. It is a very good source of silica that can be made in the nano form. And we are not to depend on any natural source for silica because rice husk can be cultivated. It has been cultivated and it is a waste material. So we are cultivating the nano silica particle, which are very much useful for providing waterproofing properties to the concrete and to the geopolymer. And of course, it is a heat insulation also provide. In the era of energy saving, in the era of climate change, in the era of global warming, there is first and foremost need is of building material to have a coating which at least give minimum heat insulation in general to save a lot of energy in acids for very survival of the people in Asian countries because it is a heat insulation, it is a heat storms which harms more. Of course, the Renka group from Russia has advanced very fast in fast and cost-effective construction, that is geopolymer concrete by 3D printing. And they hope the novelty is going to be live with this, cannot depend on only raw materials like fly, slag, etc. We got to use localized soil mineral strata using one part technology of geopolymer, making it, developing it, and optimizing the processing parameter to make geopolymerizable inorganic resin called so far geopolymer. The future is not going to depend on only on cement factory for cementitious material because to have one cement industry, it one man can it is a capital investment because the normal public cannot do it. But in geopolymer, one part geopolymer using localized soil mineral strata, it can be done at very localized area by minimum training all over the world. And that is the beauty of geopolymer, that it is a universal material for all the people by all the people. Whereas the cement industry, it is a capital investment. The investment is too high. People say that geopolymer is costly. I wonder Why it is costly? Because we need to have heat cure sometime, but no, sir. One part geopolymer is able to set at ambient temperature. As far as cost of sodium hydroxide is concerned, sodium hydroxide cost there really sodium hydroxide industry has not been aware of use of sodium hydroxide at global level for so much quantity. There is a demand supply gap. I had been to very chlor-alkali industry association in India. They told that all the chlorine alkaline NOH producer industries are using their facility only up to 60%. That can be increased. And the cost of cement, which is made using firing the clinker of lime, releasing carbon dioxide, silica, at 1450 degrees centigrade for 4 hours. So how much temperature cost is required, how much refractory cost is required, how much maintenance is required in comparison to precast geopolymer by heating it only 60 degrees centigrade for few hours. So that is a I will like to request all the dignitary to emphasize this point for misconcept about geopolymer that it is costly than cement. If 1450 centigrade for 4 hours its cost is less, then how 60 degrees centigrade for few hours can be more costlier than that? Yes, sir. Now we all know that there is a too much need of infrastructure for runways, road, and precast housing. And we are very fortunate that especially China and India, at least they have gone for infrastructure at a very fast speed, and it is to be appreciated wholeheartedly. But in the European countries, in the USA, the structures have been very, very old. There is a need to have a new infrastructure which enables fast setting materials, which can be have repairing of all these things. So therefore, geopolymer has the potential to be used in precast construction. Now the era has gone when we used to make on-site in-situ houses. In USA and European countries, already they are making their houses, their structure, all are based on prefabricated building material component. And why not Asian countries should do so? Because the 3D printing and the precast construction is possible in 24 hours. We can deliver the product, and that is how going to make geopolymer a cost-effective alternative by working on precast, prefabricated materials for infrastructure, for road, for precast housing, etc. So this inherent property of geopolymer make it efficient for precast construction too, and it is yet to be explored significantly. Yeah, I was fortunate that my team at CSIR AMPRI Bhopal, we had generally people say ki, what is the durability of geopolymer? Is it practically possible to have a demonstration to use in public? Yes, sir. The civil engineering team of my group, Dr. Manish Mudgal, Mr. R.K. Chauhan, Dr. Akram Khan, and all my colleagues, Dr. Sarika Verma, Dr. Dipti Mishra, we all have demonstrated cement-free concrete road using geopolymer for public use in the premises of AIMS Bhopal, India, and the road was constructed in between the conventional cement concrete road to see the durability, to evaluate the properties, because from the same road we have compared traffic control, traffic running vehicles load, and along with geopolymer as well as conventional concrete, and we found that there were cracks in conventional cement concrete, but theoretically there cannot be any crack in geopolymeric structures, geopolymeric materials, because it is highly viscous in nature and shrinkage is definitely compared to conventional concrete is very less. So this road has been made for public utilization and it is in use. Similarly, we were the first in the world to be appreciated by Professor Deotovit, who is the father of geopolymer invention. He, one of the geopolymer camp, has especially mentioned that for the first time in the world, on-site in situ construction of a small house, though maybe it was done by CSIR AMPRI Bhopal. And that is the confidence we have that geopolymer utilization for public utility, for infrastructure is not far away if we all are working together in a collaborative manner by arranging appropriate funding. Yeah, already people at Australia is the first to work on very vigorously on geopolymer. They have made a runway, they have a road, they have precast housing also. The precast panels making, I think it is the most simplest things to do with geopolymer. Within 24 hours, same mold can be used in every 4 hours, and we can construct multi-stories using precast panels of geopolymer. As we are well aware that Australia, they have a 4-story high building for general public use. Now, apart from that, see, if you look at the things, what area is needed for doing research? As we know, we are living in the era of radiations. We use mobile, there is a radiation. The energy production from nuclear power plants, there is a radiation. We go to hospital for diagnosis, there is a X-ray, there is a MRI. So we are more surrounded by radiations. And the radiations are conventionally shielding, there is a need of radiation shielding materials. And the shielding materials all can be made using industrial waste. For example, why? Because general conventional geopolymer shielding concrete are made using heavy weight aggregate. For example, hematite, magnetite, or barite ores or iron ores in conventional cement matrix. In conventional cement matrix, because it is not a viscous material, there is a segregation of heavy aggregate used for making radiation shielding concrete, and therefore we cannot achieve homogeneous radiation shielding matrix using conventional cement concrete. Whereas in geopolymer, because it is viscous in nature and possesses chemical binding with aggregate as well as reinforcement, so it enables segregation-free, homogeneous radiation shielding matrix and enhanced mechanical strength due to excellent binding of aggregate and reinforcement to geopolymer matrix in ITZ, also giving heat and fire resistance property in addition. So this is the property of geopolymer, which is to be exploited very fast for making radiation shielding material. We at USA, under the umbrella of Louisiana Tech University, in the guidance of Director Technology Center, Dr. Matthew, and with the help of founders of LKV Geopolymer Solution, we have developed EMI radiation shielding material, that is radiation from mobile. Nowadays, there cannot be any structure, sensitive structure, without EMI radiation shielding properties. And we are on the way to develop X-ray shielding, gamma shielding, neutral shielding properties for which is the immediate need for strategic application as well as civil applications. Yes, the radiation shielding is required for diagnostic and radiation treatment, nuclear power plants, advanced bunkers, etc. Now the next avenue I would like to explain you little bit. Yes, please. I hope, is there any some more time for me?
Yes, sir, you can continue.
So now the biggest area challenging is for air, we have carbon dioxide, geopolymer is the solution. For thermal power plants, there is a fly ash, there is a carbon dioxide. We are able to use carbon dioxide sequestration, we are able to use fly ash. We have steel industry, we are able to use all the waste from steel industry as a slag or iron ore fines or mill scale or red dust, everything for making geopolymer with improved properties. If you have nuclear power plants, we have material for making radiation shielding material using geopolymer. There is a radioactive waste which can be ideally and most effectively can be encapsulated in geopolymer matrix. The next area after air, water, and industry lies is water conservation and sea coast production. Fortunately, geopolymer can be made using various alkaline ions, for example, sodium, potassium, and these are the ions which can behave as a ion exchange ions membranes. So therefore, pervious geopolymer concrete can be used as a removing pollutants from water bodies, and again it can be used as a infiltration of flowed water. As we know, in recent there is a frequent occurrence of tornado and hurricanes and flooding in the sea coastal area all over the world. The solution is if we can have pervious concrete made using geopolymer, because geopolymer being a sea water resistant is useful for infrastructure production and newer construction at seashore for all the industries. All the industries, major industries, even in India or all over, they are always on seashores. And because of seashore, there is a corrosion of reinforcement, and geopolymer, steerable geopolymer solution addresses repair of and construction of newer material using geopolymer sprayable or geopolymer material formulations depending on the extent of corrosion to be inhibited. Yeah. So this is what some development has been done, water conservation and sea coast production at my company at LKV Geopolymer Solution in collaboration with Louisiana University Trenchless Technology Center, for which Dr. John Matthew is director.
From stormwater runoff, such as on-site infiltration, water, and uses of removal.
Now, the last topic avenue I am going to discuss about is advanced geopolymer. That is a just to understand how to go for large scale commercialization of geopolymer material. The only way is making one part geopolymer, because it will help to overcome the problem of frequent change of characteristics of raw material used for making geopolymer, because we can tailor the properties of geopolymeric powder cement using solid state geopolymer formulations, where depending on the various application spectrum and desired functionality. And therefore, we are here already patented a advanced technology for making one part geopolymer using mechanochemical, which is capable of making geopolymer powder in solid form, which needs only water to be added, and the formulations are different for each application. Depending on the requirement of functionality, they can be very fast set, they can be very delayed set. They can be used for on-site in situ construction, they can be used for 3D printing, and many applications. One of the, if audience is more interested in knowing in detail, we have published a chapter on advanced geopolymer technology and come out with a novel mechanism, how it is going to work, how the mechanochemical iteration energy is helping us in making formation of unstable siloxane species from siloxane, that is quartz silicosis. So this is the figure depicting how the solid state chemical transformation taking place using sodium silicate, sodium aluminum silicate, sodium aluminum oxide. And this is just to show an example. But all the, depending on the application, this raw material can be changed to achieve functionality, whether it is for making radiation shielding material or any other application specific. And we have come out with a new mechanism which confirms that it is a unimolecular nucleophilic substitution S11 mechanism, and in presence of water, phenol from SiO linkages, and geopolymeric gel is then formed, which on drying produce advanced geopolymeric material with considerable enhanced properties at ambient temperature. Before concluding my session, I am really highly obliged to all of you, sir, for your patience listening. And the basic idea, again, I request you, if there are some few questions, I'll be happy more to answer them, because I am not here to deliver a keynote address. I am here to learn from all of you how we can benefit each other by our expertise available with us. By our institution, we can always have supplementary and synergistic expertise in the form of experimental facility, catalyzation facilities, expertise, because geopolymer need a truly interdisciplinary area when we are want to work on geopolymer. It needs chemical engineer, it needs mechanical engineers, it requires computer engineers, it requires all the faculty for image shielding. We need wonderful physicists for, and finally, again I thank my colleagues at Translation Technology Center at Louisiana University for all the help rendered and constant support. And again, I am highly obliged to the organizer of ICCCMS 2022, all the plenary and speak note keynote address, all the students who have spared their valuable time and have a patience listening. And I will be more than happy to create collaborative opportunity for all of us. We need young people, we need young professors, we need all people are expertise, so that we can come out with some concrete collaboration plan, so that we can visit each other we can try to get jointly funding and work on these facilitating areas. At the last but not the least, my special thanks are to Dr. Bilson S. Thomas, who has taken so much pain to follow me up. Because as you know, in India you have morning, but I am here at around 11:30 night PM. So I have troubled a lot to Dr. Bilson S. Thomas, and really I appreciate his patience with me. And at the last, I am highly obliged to have a constant support, constant guidance from Mr. Mike Higgins, who is the